Happy morning, dear friends. Here's Dr. Ajanta. Welcome to Demystify with Ajay. Dear friends, today we are going to discuss a very important topic. It is on future selection techniques in machine learning. While developing the machine learning model, only a few variables in the dataset are useful for building the model, and the rest features are either redundant or irrelevant. So if we input the dataset with all these redundant and irrelevant features, it may negatively impact and reduce the overall performance and accuracy of the model. So hence, it is very important to identify and select the most appropriate features for the data and remove the irrelevant or a less important feature. So which is done with the help of future selections in machine learning. And future selections is one of the important concept of machine learning, which highly impacts the performance of the model. And yes, here we are just going to discuss different future selection techniques for machine learning. See, but let's first understand some basic information related to future selection. What is exactly future selection? You see, a future selection is futures is an attribute that has an impact on a problem or is useful for the problem, and choosing the important features for the model is known as future selection. So each machine learning process depends on future engineering, which mainly contains two processes, that is which are future selections and future extractions. Although future selection and extraction process may have the same objective, both are completely different for each and other. So the main difference between that is, the future selection is about selecting the subset of the original feature set, whereas future extractions creates a new features. Okay, so future selection is a way of reducing the input variable for the model by using only relevant data in order to reduce overfitting in the model. Dear friends, actually till now we didn't specify anywhere about this overfitting or underfitting like this. Of course, we are going to discuss in coming forth sessions. And what is the exact need of this future selection? Dear friends, actually what as we have discussed what is this, and before implementing any technique, it is really important to understand the need for this techniques. And so for the future selection, okay, so as we know, in machine learning it is necessary to provide a pre-processed and good input data set in order to get a better outcomes, and we collect a huge amount of data to train our model and help it to learn better. So generally the dataset consists of noisy data or irrelevant data and some part of unuseful data also. So moreover, the huge amount of data also slows down the training process of the model, and with noise and irrelevant data, so the model may not predict and perform well. So it is very necessary to remove such noises and less important data from the data set. And to do this, future selection is very much useful. And selecting the best features helps the model to perform. Say for an example, suppose we want to create a model that automatically decides whether which car should crash for a spare part. So, and to do this, we have a data set. So this data set contains a model of a car, or year of manufacturing, or owner's name, or what is the miles it has traveled. So in this data set, the name of the owner does not contribute to this model performance, and it does not decide if the car should be crushed or not. So we can remove this column and column or this attribute and select the rest of these features which we are going to make use of that, and let me just build the model. So yes, dear friends, of course, the main benefit of this future selection is avoiding the data that is it is not needed like that. So it helps in avoiding the cruise of dimensionality. And yes, it helps in the simplification of the model. So yes, this exact simplification of the model so that it can be easily interpreted by the researcher. and exactly it reduced the training timing. And of course, as I have already specified, it just reduced the overfitting and hence the generalization. And we are just going to discuss this related in coming forth sessions. Okay, yes, so here coming towards this, what are all the techniques? Of course, there are many type of techniques are there, and mainly two types of future selection techniques here. It is categorized as like supervised future selections and unsupervised future selections. And today in this session we are just going to discuss about this supervised future selections. And kindly just have a note on towards this, dear friends. So this future selection, that is a supervised method. There are three types of different methods is there. One is a filter method, and embedded method, and wrapper method. Okay, so let me just see one by one. So yes, so first of all, let me just go on to this filter method. Dear friends, in this filter method, futures are selected on the basis of statistics measurements, and this methods does not depends on the learning algorithm and chooses the futures as pre-processing step. As pre-processing steps is in the sense, dear friends, here the filter method filters out the irrelevant futures and redundant columns from the models by using different metrics through ranking. Okay, and the main advantages of using filter method is that it needs low computational time and does not overfit the data. So we are just going towards this. And coming towards these methods, of course, we have so many things is there as like information gain. Yes, information gain determines the redundant in entropy. Yeah, we would detailedly discuss this in decision tree. And while transforming the data set, this exact entropy would be useful. And it can be used as a future selection techniques by calculating the information gain of each variable with respect to the target variable. Okay, and here, dear friends, of course, I'm just going to take as simple data. Okay, of course, I just have to show how this is happening. So yes, let me just implement it with an Python programming. Yes, we are having here with basic necessary libraries. So NumPy, Pandas, and to have a view of those data, I'm just using Seaborn and Matplotlib, and yes, with an warning data. And yeah, by using this, let me just have this iris data, which is very much pre-processed data, and let me just have this. So kindly have an view of this, and of course I have just given this head to view this only the top 5 records. And of course, dear friends, here I'm just going to have the future selections from the sklearn, and this it is related to information gain. So as I have already specified, dear friend, this information gain calculates the reduction in entropy. Okay, and this is exactly for about the columns. And kindly just to see here, of course, this spices is the target, so I'm just dropping it. And so here we just have the X and Y column. So okay, so this is the X futures and the Y futures. Simply just we want to make a pre-processing, and with this column for mutual information classification, we are just making this. Okay, and towards this, let we have a view of this chart. So kindly just have a view. Okay, so this is how it just shows. So of course, every variable here, whatever this it is appeared, yeah, we are using that data. And yes, as it is already, as I have already specified, it is a pre-processed data. So I'm just making use of the same thing. Okay, so nothing much here towards this first one, information gain. Let me just move on to the next one. It is chi-square. Yes, exactly, dear friends. This chi-square test is a technique to determine the relationship between the categorical variable. So the chi-square value is calculated between each future and the target variable and the desired number of futures with the best chi-square value that is selected. And kindly just observe, dear friends, here I have just included the sklearn future selection, and with this chi, this is the exact model to be included to make this as chi-square. As I have already specified, dear friends, yes, we calculate this chi-square between each future and the target and select the desired number of the futures, so with the best chi-square score. So in order to correctly apply the chi-squared to test the relations between the various futures in the data set and the target variable, here I have just given an exact conditions that this exact chi-square, kindly just see here, k is equal to 3, I have just specified, that is, yes, this one, the value should be expected frequency, that should be here as 3. Okay, so that is what I have just provided, and let me just fit it and view it. So this is how. So of course we have so many datas. Yes, only 3 values we have just taken, and we are not aware of which model it has been selected. And kindly anyhow, let I just have a view. Okay, so see here, this sepal width, it has a lower values of what according to this information classifications. Okay, so from this it just taken the top 4, okay, sorry, top 3, and from that we just got 0, 1 and 2. Got it, dear friends? Okay, yes, fine. So now next it is all about a correlation method. Dear friends, actually here I have to specify one important thing. So when we just take towards this correlation, actually it is measures of linear relationship between 2 or more variables. So here this exact correlation, it just goes towards multivariant functionalities, and through these correlations we can predict one variable from the other. Okay, so the logic behind using correlation for this future selection is that good variable that is correlate highly with the target. So furthermore, variables should be correlated with the target but uncorrelated among themselves. That is mainly this would be helpful by using this correlation matrix. And yeah, if 2 variable are correlated, we can predict one from the other. So therefore, if 2 future are correlated, the model only needs one, as the second does not hold any additional information. So we use mainly here we just use Pearson correlations also. That is also very much important. And yes, let I just make use of this. Let me just go with the same data set, iris data, and for correlation, let me just have a view of this matrix, and kindly just observe here. And yes, dear friend, here, yeah, we need to set an absolute value. Okay, here if you are just selecting any threshold values or whatever be, okay, so if we find that the predictor variable are correlated, yeah, we can drop the variable with a lower correlation coefficient value than the target value variable. So we can also compute multiple correlation coefficients to check whether more than 2 variables are correlated or not. And of course, dear friends, this phenomena which we just if we are speaking about this linear algebra, or linear regression, yeah, it is mainly noted as like multicollinearity. Okay, so that is what I have to add about here. And yes, next one, it is all about ANOVA test. Dear friends, of course you are all aware about this ANOVA. So this is also exactly towards the variable how many variables do you want to have it, and here also the exact variables I have just specified as like 3 variables. So here I have just specified k is equal to 3, and with that we are fitting our data, and here it just creates a data frame with that 3 variables. Okay, so of course this is what the first main important data. Okay, so that is the technique under supervised, and next we are just going to discuss about wrapper method. Yes, in wrapper methodology, this selection of a future is done by considering it as a search problem. So in which different combination are made or evaluated and compared with other combinations. So it trains the algorithm by using the subset of future irrelevantly. So see here, of course, here we are just making the selection of futures, but here, yeah, which future do you want? This is the exact one. The best future is selected here. This is the exact main methodology. Okay, yes, and coming towards this, there are few functionalities, few techniques are available. Let me just discuss one by one, and here we just go with forward future selection. Dear friends, to make this forward future, I just want to include this ML extend information, and I just make use of it, and kindly just include this package, and let me just go for the first one. Okay, so as I have already specified, yeah, we are with the discussion of forward future selection. Dear friend, forward future selection is an iterative process, as I have already specified, which begins with the empty set of future. After each iteration, it keeps adding on a futures and evaluate the performance to check whether it is improving the performance or not. Okay, so if the exact process continues until the addition of new variable or future does not improve the performance of the model, so till that it just makes use of it. Okay, so let me just make the same thing here. Here I have just provided the exact future number, which is equal to 3. And yeah, dear friends, actually here I have used a logistic regression to make a classification functionalities, and with this function of selecting the future selection, okay, I have just given this logistic regression model and making the future functionality. So that is what here this classifier it is provided, and let me just fit and towards this. Yeah, it just takes a few seconds to make the fit of data towards our data set. Yeah, here we just got the logistic regression model, and what is the exact future name that has been selected is, yes, sepal length, petal length and petal width. And what is the one which we are missing is a sepal width. Yes, of course, dear friends, kindly I just have a view. So this is what which we are having the least one. Yes, we are removing, or maybe it is not matching performing well. So we are just taking the other 3 futures as a selection, and we are proceeding for the model. Okay, next it is all about backward future elimination. This backward future elimination is also an iterative approach, but it is in the opposite of forward selection. This techniques begins and process by considering all the futures and removes the least significant futures. So this elimination process continues until removing the future does not improve the performance of the model. Okay, and here also I just have the exact future, and kindly have a view and let it fit. And here we go with the future. Yes, of course, here also the exact. So kindly just here I just show. Okay, so here also the least one which is which we are plan to remove, it is a sepal width. Okay, yes, yeah. Next we are just going to have the embedded method. Okay, so dear friends, this exact embedded method combine the advantages of both filter and wrapper method. So by considering the interaction of the future along with low computational cost. And these are fast processing methods similar to the filter methods but more accurate than the filter method. And here, of course, there are two important functionalities is that one is the regularization and the next one it is random forest importance. And of course, I'm just going to handle a separate session for regularization. Here, I'm just included this random forest. Okay, yes, dear friends. So, random forest, coming towards this random forest, yes, different tree-based methods of future selection helps us to futures importance to provide a way for selecting the futures. So here future importance specifies which future has a more importance in multiple or model building or has a great impact on the target variable. So that is what it is selected. And random forest is such a tree-based method, so which is a type of bagging algorithm that aggregates a different number of decision tree. And yes, dear friends, this algorithm also we are just going to discuss in decision tree. And of course, this random forest it is comes under ensemble techniques. Under that. Towards the bagging categorization we would discuss in detail. Okay, so coming forth with the algorithms, and yes, it automatically ranks the nodes by their performance or decrease the impurities, that is which we just say Gini impurities. Okay, so overall the trees, so nodes are arranged as per the impurities values, and that's it also allows that pruning of the trees, that is also very important. We are coming towards this overfitting. Okay, so below the specific nodes. So the remaining nodes creates a subset of most important futures. So that is what here. And let I just have this execution. So yes, here it is going to have model, and kindly just observe the models. Okay, so here it just shows the important futures. Okay, so coming to the end, dear friends, of course here we are just discussing about how the future selection has to be chosen, which method or which model we have to choose. And yes, it is very important to understand that which future selection method will work properly for their model. So the more we know that the data types of the variable, so the easier it is to choose the appropriate statistical measure of future selection. That is very much important. So to know this, let me just categorize as like numerical and categorical. And here I just want to add up one thing, dear friends. If you are inputting in what is the exact whether the variable it is a numerical variable or a categorical variable, and kindly just observe, dear friends, this exact numerical variable here, this exact numerical variable which has a continuous values as like such as integer or float. And when coming towards this categorical, of course variables with categorical such as like boolean or ordinal or nominal comes under this. Okay, and with this, if you are having a numerical input, and what would be the output? If you are having a numerical input, and to the same if you are having the numerical output, okay, so yes, you can make use of Pearson correlation coefficient and Spearman correlation coefficient, rank coefficient, and kindly just observe where to use this. And if it is a linear correlation, kindly make use of this Pearson. And if it is for non-linear correlation, yes, kindly make use of Spearman rank correlation. Okay, now you are having an input as numerical variable, and if you are having a categorical output, of course, there are very too much important things. So, numerical input with categorical output in case of classification predictive modeling problems. Okay, so in this case also correlation based techniques should be used, but with categorical output. Kindly just be aware of it. And coming towards this, when on having this categorical output, if it is linear, kindly just go with ANOVA correlation coefficient. And if it is a non-linear, yeah, Kendall's rank coefficient. If it is a non-linear, kindly just go with a Kendall's rank coefficient. Next, coming towards this categorical. So, categorical input, what would be the output? Yeah, further again, it can be numerical output or categorical output. Okay, let me just take the first one. Yeah, as like categorical input and taking numerical as like output. And this case, yes, regression predictive model with categorical input, it is the main thing. Okay, and it is a different examples of regression problems. So we can use the same measure as we have discussed, but in a reverse manner. Reverse manner is in the sense, yes, for linear, kindly make use of Kendall's, and for non-linear, kindly go for ANOVA. Okay, and yes, coming towards this categorical input and categorical output. So this case of classification predictive model with categorical input variable. Okay, so the commonly used technique for such a case, it is a chi-squared test, and yeah, we can also use information in such a case, in this case also. Okay, and if it is a continuous table, kindly just go with chi-squared. Okay, yes, yeah, dear friends, so here we just conclude for this today's session, and kindly I just let you know this future selection is very complicated and vast field of machine learning, and lots of studies are already made to discover the best method. There is no fixed rule for the best future selection method. However, choosing the method depends on the machine learning scientists who can combine and innovative approaches to find the best method for a specific problem. So one should try a variety of models that fits on different subsets of futures selected through different statistical measures. So I think, yeah, dear friends, here we conclude today's session. If you like, kindly just put a like and kindly just subscribe the channel if you not yet done. And yeah, dear friends, kindly share to those who are in need of this resources. Okay, and yeah, see you in another video, and happy learning, dear friends.